Good morning. This is KAP for Wednesday, March 24th. We're starting off the class with a ticket, so if you miss class, make sure you find a time to make that up with your teacher. Today, there's like a little sort of reintroduction to inequalities. We know it's been a minute since you've done these. Probably did a lot of it in elementary school. We're just going to be bringing those back and sort of adding on to it and applying some stuff we've already learned to inequalities. So just as a reminder, with inequalities, that's like the less than sign, the greater than sign, and we're going to talk about a few others. When we talk about an inequality, we are talking about a mathematical sentence that compares quantities. And equations compare quantities as well, but with an inequality, they are two quantities that are not equal. One's going to be bigger, one's going to be smaller, one's going to be greater than, one's going to be less than. Again, in an equation, they're equal. This is the difference, is they're not equal in inequalities. If a value is called a solution, again, solutions make things true. Okay, and we're going to talk about solutions like equations. That's when I found what x equals 4 and stuff like that. Inequalities, it's similar but a little bit different. Okay, so again, we're going to review the symbols, the signs, words that mean it, and we'll do some examples of inequality. So less than goes this way, looks like an L, less. That's sort of how you can remember. Looks like a L, so you would say like this number is less than this number. I'm going to take that little thing out. And then greater than, of course, is the flip of that. Words that mean less than, fewer than is another way to say it. Must be under. Just stuff like that, must be less than. All that good stuff. So an example would be like 3 is less than 5. Remember, your teachers probably taught you like the alligator. This is like an alligator mouth, and it's always going to eat the bigger number because it wants the bigger meal. That stays true, friend. Of course, we can apply some like algebra type stuff using variables. That's sort of how we'll tweak it for 6th grade. So I could say, oh, x is less than 5. And so think about what values could x be. Okay. Oh, it could be 2, it could be 4, it could be 0, it could be a bunch of numbers, it could be negative numbers, it could be negative 10, it could be rational numbers like, oh, 3.5. It can't be 5, like 5 isn't less than itself, it's equal to itself, not less than itself. But there's a whole range of numbers. So that's something that's a little bit different. Again, all of these red numbers are considered to be solutions because they make it true. So think back, equations have one solution, inequalities have quite a few. Okay. Again, on the flip side of that is the greater than sign. So that's going to be opening, this number is greater than that number. A student of mine, that less than thing where I said, oh, it makes the L, he showed me, there was a student a few years ago, he showed, that's horrible. So it's the greater than symbol, and then it makes a G for greater. It was cute. I liked it. All right. But again, we always read inequalities left to right. So you'd say this number is bigger, this number is greater than. All right. Greater than, more than, must be over. Okay. There's tons of examples, but that's just a few to use. An inequality example, 10 is greater than 7. Okay, that's a true statement. 10 is bigger than 7. Let's apply some variables to it. So R is greater than 7. So what are some values that R could be? It could be 10. It could be 27. It could be 8.5. It could be 7.001. Like it could be so close, but that's still more than. But it can't be exactly 7. Okay, because again, 7 isn't greater than itself. You can't say that. And of course, you can do real world. Oh my gosh, do you see inequalities all over the world? So like a greater than example, let's say like a business. In order for a business to make profit, Their earnings has to be greater than their spendings. You have to make more than you spent. So it must be greater than its spendings. It can't be equal to its spendings because then you don't make a profit. It's just zero. But yeah, and so there's tons of examples. So these next two are a little bit different, okay? These are sort of new probably to you, but it's working off of what we already know, okay? There is the less than or equal to symbol. What it is it's the less than symbol with a line underneath it, okay? Something can be less than or equal to. At most, no more than, no more than, no greater than, lots of things. Okay, so I love to give real world. These are very real world relatable, no greater than. So like I told my classes at Chick-fil-A where they have like those play palaces or whatever fast food restaurants, there's usually like some age limit and it might say like you can be no more than or at most 13 years old to play. Okay, that means you can be 13 and play on there. You can go down that slide all you want, but you can be no greater than that. You cannot be over that. So all your favorite math teachers, unfortunately, they are greater than 13 years old, so they can't go down the fun slides, okay? You can be no more than 13 years old to go down the slide, okay? So an example, I'm going to just do an algebraic one. So like x plus 3 is less than or equal to 10. The sum of these two is no more than 10. So of course, again, I can plug in several values to make that true. I could plug in 3 because 3 plus 3 is 6, which is less than or equal to 10. That makes it true. I could plug in 0. I could plug in, let's do 7. If I did 7, that'd be 7 plus 3 is less than or equal to 10. 7 plus 3 is 10. And that's true. 10 is less than or equal to 10. Because of that line, I can make it exactly equal to it. So 7 works. And of course, any rational numbers, 2.5 and so on and so forth. Okay? But again, the main difference, because it has that line, that means it can be equal to the other side. Okay? On the flip side of that, I bet you can guess that the greater than or equal to sign is going to be the greater than or equal to, just with that line. Okay? So you must be at least, you can be no less than. So great examples, you can be, you have to be at least 16 years old to have a driver's license. Your age must be no less than 18 to vote. So in those cases, like for the driver's license, you have to be at least 16. If you're 16, you can have it, or more. Your age has to be exactly 16 or more. For voting, 18 or more works out. Okay, so it's again where it can be equal to that value or higher. So I'm going to take this inequality and I'm just going to flip the inequalities and I'm going to take x plus 3 is greater than or equal to 10. Again, I'd say I read it left to right, x plus 3 is greater than or equal to 10. So let's talk about possible solutions. X could be 7. That's a cool thing, is that 7 plus 3 is 10, which is greater than or equal to, because it has that line. That works. But then we're looking for bigger values. I don't want smaller numbers. I want bigger. So like, again, 38, 1,000. I could go until the moon doesn't shine. And 4 point, I can do, of course, those decimals. Okay, so again, with inequalities, there's more than one answer for x. There's a range of numbers. Okay, so first we want to just practice writing. If I see a situation, writing the inequality that matches that. So I'll do a couple with you, and then I'll let you do a few on your own. The big thing to remember is that we're comparing two things, so I'm always going to have one thing on one side, one thing, something else on the other side. With 6th grade math, we're going to tend to have a variable, so something that's going to change a letter or an unknown quantity, stuff like that. So look for that. So first situation says you must be over 12 years old to go on the go-karts. Okay, so the thing that's going to vary in here is like the age. So I'm going to say A is going to stand for my age. because if we're looking at different people, it's going to change depending on the person. I need to compare that. I'm comparing my age to what number? I'm comparing it to 12. So I'm going to put them on either side of the inequality. Then I need to figure out what is what. Okay, so if I must be over 12 years old, can I be exactly 12? No, I can't. Okay, I have to be over that number. So that means it's not going to have the line. It's not going to be equal to. Okay, and again, does my age need to be bigger than 12 or less than 12? My age needs to be greater than 12. So that's the inequality that matches that. Okay, number 2, you must be at least 16 years old to drive and have a driver's license. We talked about this one already. Again, the thing that's going to vary, the thing that's going to change is my age. It's going to be different depending on each person. I'm comparing that to what number? I'm looking for a number. I'm going to compare it to 16. Okay, so again, can I be exactly 16 years old? If I have to be at least 16 years old, at the minimum, I have to be 16. Yes, I can be 16. And then my age needs to be greater than that. Okay, because if I'm 18, does that work? Yes, 19. Okay, you can always plug in numbers in your head and be like, okay, yeah, that works, and the inequality matches that. Okay, so try those next 3. Just a reminder, quotient, that's the answer to what kind of problem? It's a division problem, so just keep that in mind. Okay, pause and play when you're ready. Okay, you must be no less than 13, so it's again another age one. There's a lot of age problems. I'm comparing my age to 13. If I can be no less than 13, I can be exactly 13 and play in the basketball league, but I can't be less than that. I have to be greater than or equal to 13. The quotient of x and 3 is less than or equal to 5. It tells me the symbol right there. The quotient of x and 3, so that means I need to take x and divide it by 3. I'm comparing that answer to 5. If it is less than or equal to, it's going to have that line, and that quotient is going to be less than or equal to 5. It's going to eat the 5. Next one, the difference, that means to subtract between x and 4 is greater than 10. Because it says difference, I don't need to flip this. It's only when it says fewer than, less than, that I flip the things. So the difference between x and 4, I'm comparing that to 10. That difference is greater, so I'm going to put it like that. Okay, so that's just some practice on how to write. We'll do that more and more as we get harder and harder, but that's just the sort of starting of it. Of the given values, 6, 7, and 8, determine which ones make the inequality, this inequality, true. So I need to plug those numbers in for f. So I'm going to do 6 plus 2 is less than 9, 7 plus 2 is less than 9, and 8 plus 2 is less than 9. I need to see which one makes it true. 6 plus 2 is 8. Is that less than 9? Yep. 7 plus 2 is 9. Is that less than 9? No, it's equal to, and it doesn't have that line, so nope, that doesn't work. 8 plus 2 is less than 9. 8 plus 2 is 10. Nope, that didn't work. So the only one that worked of those given solutions, 6 is the only one that worked. There's other numbers out there, like 5 would work, 4, 6.5 would work, but of the given ones, that's the only one that works. So if you want to pause and try this one out, go for it. In that one, the only one that works is 10. 10 is my solution. Okay, so a little bit more talking about how to graph them. Now, let's just do a quick review. When I had an equation like x plus 4 is equal to 10, x was equal to, x had to be 6. Okay, so when we graph that inequality, or sorry, when I graph that solution, I always put a 5, 6, 7. I put that number and then a number on either side, and it was only one number. So I'm going to graph, the answer is 6. It's only one number in equations. There's only one that makes it true. I can't plug in 7. I can't plug in 5. Okay, so that's going to change a little for inequalities, and it'll hopefully make sense. So in this, I want to graph the solutions. X is less than 5. So again, I'm going to go ahead and put 5 on my number line, and a number above and a number below. So 4, 5, and 6. Okay, so let's ask ourselves, what values makes X true? And maybe let's put a number on either side, 2. This, usually I don't put 5 numbers, but I'm just doing it just in case. So let's start with 5. Can I make 5 an answer? 5 is less than 5. No, it doesn't work. But then I like to go to either side. So I'm going to plug in 4 and I'm going to plug in 6, see which one works. Okay, 4 is less than 5. 6, that doesn't work. Okay, so I'm looking at numbers this way. Now, it's not really going to make sense for me to do like a dot for every single number that it could be. And let's also think, okay, what about these numbers in between, like 4.2? Yeah, that works. 4.5, 4.9. Oh, I can get so close. 4.9999999. I can get so close to 5, but I can't be exactly on 5. You know, sometimes it's hard to read the difference between like 4.9999 and 5. So what they do is we put an open circle on 5. We're saying the answer isn't 5, but it's pretty close. And then we're going to draw an arrow this way and say it's every single number. Okay, it's 4.9999, it's 4.5, it's every single number this way. 3, 2, 1. Okay, so when we graph our solutions, we're showing that there's a ton of answers, but it's from not 5, but everything else this way. Okay, we have that open dot because I can't include 5 in that solution set. Okay, so let's just go through it and hopefully it'll click a little bit if that's not making too much sense. So again, I'm going to put -8. When X is by itself, it's going to be -8. And then I'm going to put a number on each side. With negatives, remember it's flipped. Okay, so start with the number. Can -8 make this true? -8 is greater than -8. No. Okay, but let's see. Again, it's going to be pretty close to it, so it's going to be one way or the other. I'm going to use -9 and -7 to plug it in. Which one is greater? Now remember, with negative numbers, the bigger the negative, the smaller the number. The less is always on the left, least to greatest, if you remember when we did that at the beginning. So if I want the bigger, I want all the numbers this way of -8. So it's going to be, again, I can't include -8, but it's going to be like all the numbers so close that I can't tell. And then every single number this way on the number line. So 0 is greater than -8. 100 is greater than -8. So that's all the numbers this way. Okay, so that was the less than and the greater than. These have the lines. So let's see how that's going to change my graph. Okay, put one on each side. Oops, I didn't make my small. So -2, -3, 1 on each side. So again, start with the number. Can -2 be used in this? -2 is less than or equal to -2? Yes, it can, because it has that line. It can be equal to it. So I want to include -2. So instead of an open dot, I want to include it with a closed dot. But again, -2 isn't the only answers. I can have multiple, but is it going to be this way or is it going to be that way? I want all the numbers less than -2. Remember, less is on the left. These are greater. So I want all the numbers this way. -100 is less than -2. Every single number this way. Okay, so that's the difference. That line means I can include that number. Let's do one more and then we'll recap that. So I need 10 and then a number on each side. Start with 10. Does 10 make this work? 10 is greater than or equal to 10. Yes, it's equal to. I can include it. So I'm going to color it in because I can use that number. Then which one makes it true? 11 and all the numbers this way make it true. So again, what makes it filled in? What makes it open? Okay, what makes it open is I cannot include 5 in this. I can't say 5 is less than 5, but I can get so close to it that it hurts. Okay, so I'm just going to put an open circle and say I'm not including it, but I'm including everything that way. Again, -8, I can't put it in that, but I'm going to get so close and include all the numbers this way. When it has the line, it can be equal to. It can be the same as that value. So -2 can be equal to, so it's closed in, I'm including it, and then it's every number that way. Again, 10, I can use it in there, and then every number this way. When it has the line, it's closed. When it doesn't, it's open. Okay, so pause, and I want you to try these 4 on your own. You might have to, if you're doing the notes on your own at home, you might just make a number line. You can just put the one number and a number on each side. So like for this first one, you would have 9 and then 8 and 10. You don't have to put the whole thing. Okay, pause and play when you're ready. Okay, number 3, open or closed. It's going to be an open dot on 9, and then it's going to be towards the 8 or the 10. It's going to be towards the 10. All the numbers that way. Number 4, think open or closed. It has the line, so that's going to be closed. Which one makes it work? 7 or 9? 7 makes it work. Number 5, can I have 15? Nope, so it's going to be an open circle. And then I want the numbers less than that. Okay, and then last one, open or closed? Closed, and I need the numbers greater than, so it's going to be that way. Okay, last little bit, of course, is just applying a word problem to an inequality. The number of text messages Leela sent each month is shown in the table. She can send no more than 55 messages. If she can send no more than 55, we want numbers less than 55. So if I'm saying T is the number of text messages, I'm comparing that to 55. I can't send more than that, but I can send exactly 55, and I want numbers less than it, and that's exactly what they did. I just want to keep practicing writing that inequality. So use the inequality to determine which months she exceeded. So where did she exceed? Where did she go over her limit? Looks like January and February. Okay. If each additional text message costs a quarter, how much was she charged from January to April? So January, it looks like she went, how many messages over? She exceeded by 1, so that's only going to be 25 cents for January. And then in February, she went over 2, so that's going to be 50 cents. So in total, that's going to be a whole 75 cents. Overall, not too bad, but we know we send more text messages than that. Okay, so I'm sort of going to let you just keep going on your own. The partner practice, it's really good partner practice because you keep practicing that graphing, writing inequalities. I highly recommend it. Okay, it is very good, and the key is on Canvas, and then your homework is posted. You also have a test review that's in Aware Now, and that is due next Tuesday, so make sure you're working on that. Thank you.